Question 11.18a. We have a total of how many carbons in our starting material? We've got 1, 2, 3, 4, 5. 5 carbons here, and we only have 4 carbons here. And so that tells us that we have to have this compound, and then we have to do an ozonolysis reaction to make that carboxylic acid. And so as far as getting the terminal alkyne, we're going to get that from the geminal dibromide like this. And of course, we can make that from the double bond. So we're going to start out by doing a bromination using bromine, of course. And that's going to give us the geminal dibromide here. And then to make the triple bond, we're going to treat it with excess sodium amide followed by water. That's going to give us the alkyne that we're looking for. And then to make the carboxylic acid, we're going to hit it with ozone followed by water. And of course, you're going to end up with this product, plus you're going to have CO2 formed as a byproduct as well. There you go. So a little bit of alkene chemistry, alkyne chemistry combined in the same problem. A total of 1, 2, 3, 4, 5 steps. This is a 5-step synthesis, 5 steps for this one. All right, let's move on to 11.18b. So this is 11.18b. So we're starting out with this primary alkyl halide. It's got a total of 4 carbons, and then it's got 5 carbons. So we're only adding 1, but we don't know any way to, well, I guess we do know a way to add just 1 carbon, but you couldn't have a triple bond and then have this, because then you'd have a pentavalent carbon. So that tells us that we have to have this molecule where we have 1, 2, 3, 4. So then we're going to have something that looks like this. Okay. So, and then of course, all we have to do is ozonolysis. And so to get from here to here, it's just one step. We're just going to take this compound and we're going to treat it with sodium acetylide. Sodium acetylide, this guy right here, and that's going to give us our terminal alkyne. 1, 2, 3, like that. And then in the last step, we're going to hit it first with ozone, and in the second step with water to give us the final product. That is not a very good looking triple bond. Let's see if I can fix that here. 1, 2, 3, maybe a bit better. Okay, 11.18c. So this is 11.18c. We're starting out with the same alkyl bromide that we were before, this compound here. And now we want to make an aldehyde. So we have an aldehyde that looks like this. So it's very similar to the previous synthesis, because the only way we know how to make an aldehyde would be well, there's actually a couple ways we could. There's a couple of ways we could do it. We could make it from an alkyne, but in that case, we're only adding 1 carbon, right? Because here we have 4 carbons. Here we have 4, 5. We've got a total of 5 carbons. And so I think probably the best way to do this would be to have this alkene, okay, which has 1, 2, 3, 4, 5, 6 carbons, and then do an ozonolysis of the alkene like that, and that would give us the aldehyde that we want. So you can see that to add these 2 carbons, we're going to use the same procedure that we used in the previous example. So we're going to hit it with sodium acetylide. In the first step, that's going to give us the terminal alkyne, which looks like this. And then we're going to reduce that to the alkene. So for that, we're going to use hydrogenation with Lindlar's catalyst. That gives us the alkene, 1, 2, 3, 4, 5, 6. And then we do our ozonolysis. So ozone followed by DMS. And that gives us our final product. There we go. All right, good. So this one is a total of 4 steps. So 4 steps, not too bad for this one. Okay, let's move on to 11.18D. And again, this is in a similar vein to the last one. So 11.18D. And this is where we're taking, this is called isobutane. It's the name of this compound. Or you could call it 2-methylpropane. And we want to make this alkene. And you can see that we're going from 4 carbons to 6 carbons. And so we need to do, the first thing we know we have to do is a bromination, right? We have no choice but to do anything but to treat this with bromine and light. And that's going to give me this compound. So I'm going to have 2-bromo-2-methylpropane. And then I'm going to have to do some kind of elimination with that. But if we go back to this, to the final product, you know, what we really need to have is we need to have this compound, because then we could combine it with the acetylide, right, in an SN2 and just reduce it using Lindlar's catalyst. So we need to find a way to go from here to here. Now, I'm going to have to use a non-nucleophilic base, I could use T-butoxide. I could use literally any base here, because since this is tertiary, I'm not going to get any SN2 with that. I'll just use sodium methoxide. You could use T-butoxide. It doesn't matter in this case. And that's going to give you isobutylene. And then we could do an anti-Markovnikov addition of HBr, which is going to give us that compound, that alkyl bromide in blue that I have at the top. So then we can treat that with sodium acetylide, and that's going to look like this. So 1, 2, 3, and then to reduce, we use hydrogenalysis. So H2 in Lindlar's catalyst. So this is a total of 1, 2, 3, 4, 5. So again, 5 steps. The 5 steps to get to the final product. Okay, so let's move on to 11.21. And I wanted to look at the first 2 questions of 11.21. So the first one is 11.21a. And in this one, we're taking isobutylene, and we want to convert it to this methyl ketone. And I don't know about you, but when I see a methyl ketone, I think, okay, well, I need to have the analogous. So 1, 2, 3, 4, 5, 1, 2. Here we go. I need to have the proper alkyne, because this I can just do a Markovnikov addition of water, and that's going to give me the enol, which tautomerizes to give me the methyl ketone. So the question becomes, well, how do I get from here to here? Well, in this case, one more retrosynthetic step is I would need the primary alkyl halide and sodium acetylide, and we've already seen how to do this on the previous example. So first step is going to be an anti-Markovnikov addition of HBr. That's going to give me the primary alkyl halide I need, like this. Okay, and then we're going to treat this with sodium acetylide, and that's going to give me the alkyne. And now that I have the alkyne, I just do the Markovnikov addition of water. So sulfuric acid, water, and mercury 2 sulfate, or mercuric sulfate, whatever you want to call it. And there you have it. Okay, one more. Let's see here. It was 11.21b. So 11.21b, it's this guy here, starting out with isobutylene again. And now we want to make an aldehyde. So it's just kind of reviewing some more chapter 9 chemistry, because this aldehyde, right, we could do a very similar retrosynthetic analysis. Watch, I'll even copy and paste this part here. So if I copy this, actually I could copy all of this part here, okay? So we copy this, and we could do the similar retrosynthesis here. It has to come from these pieces, but now you're going to do an anti-Markovnikov. So what I mean by that is this step here is going to be 9-BBN followed by peroxide and sodium hydroxide. But the rest is going to be the same thing. So what's our first step is anti-Markovnikov addition of HBr, using HBr and peroxides. That gives us the alkyl halide. We do the SN2 with sodium acetylide. That gives us the necessary alkyne, and then to make this compound, we use 9-BBN, or you could use dicyamylborane, or you could just say R2BH. Step 2 is hydrogen peroxide and sodium hydroxide. And that gives us the final compound, just like that. Just bear with me here 1 second, okay? Let's try one more. Okay, 11.21E, the last one, okay? 11.21E. You're starting out with methyl cyclopentane. It's kind of a cool problem. And you end up with this 1, 2, 3, 4, 5, 6. All right, so you end up with this compound here. But the idea here is if you're making this aldehyde, what they're trying to get you to piece together is that this part comes from a cycloalkene of some sort, right? So it comes from the ozonolysis of a compound. So if you count the number of carbons in the ring, 1, 2, 4, 5. So it's going to come from this compound. That's really the hardest part, because I think that everybody could go from here to here, right? Bromination followed by elimination. But to figure this part out is a little bit tricky. But you can see that if you break this bond, that's the compound you're going to end up with. You're going to have a ketone and an aldehyde in the same compound. So our first step is going to be bromination. Bromine and light. That gives me 1 bromo, 1 methyl cyclopentane. Then we treat it with an unhindered base like sodium methoxide or ethoxide, not important. That gives us the 1 methyl cyclopentene, and then it's an alkene, so you do ozone followed by dimethyl sulfide, and there you go. So kind of a cool problem, that one there.